Good day, learners, and welcome to Natural Science. All right, today we are continuing with our periodic table, but our subtopic is going to be what? Atoms. So this topic is well integrated. It goes in and out, and then you will understand what I'm talking about. All right, as usual, my details are on the screen, and there we go. So today, our lesson objectives are, by the end of the lesson, we should be able to explain what an atom is. We should be able to list 3 subatomic particles. We should be able to define a pure substance. We should be able to give examples of pure substances. And then we should be able to talk about what? Mixtures of elements and compounds. All right. Okay, so we're looking at atoms as the building blocks of matter. So what is an atom? Atoms are the smallest particles of which all elements are made. In fact, they are the basic building blocks of all matter. Okay, so atoms are the smallest particles of which all elements are made. And they are what? The basic building blocks of what? All matter. Okay, this includes your own body, my body, your hair, your organs, the earth on which we live on, the sun, are all made of what? Different combinations of atoms. For example, our body is 19% carbon and 10% hydrogen by mass. So you see, our body is just made of what? Matter, of which atom is the basic building block of that. All right, all known elements are arranged on the periodic table in order of what? Increasing atomic number. You remember this last week when we were talking about what? The periodic table. All right, elements are arranged into groups, into vertical columns. So you remember last week we said the vertical columns are called the groups, and then the horizontal rows are called what? Periods. And we said elements within a group have what? Similar physical and chemical properties. So if you look at group 1, we have hydrogen, we have lithium, we have sodium, we have potassium. It means they will all have what? The same physical and chemical properties. All right. Now let's look at the subatomic particles. There are 3 subatomic particles that are found inside the atom. You remember last week I tried to use this to explain to you the concept of what? Atomic number. All right, so it's coming here again. So what are the subatomic particles? The subatomic particles are, we have protons, we have neutrons, and we have got what? Electrons. The nucleus is the center of the atom and contributes most of the mass. So the nucleus is made up of what? Protons and neutrons, which are together called what? Nucleons. So what are the subatomic particles? The subatomic particles are what? Protons, neutrons, and electrons. All right, now let's go further. So this is, you remember this diagram last week? So this is a what? A simplified diagram of the atomic structure. We have the nucleus, and inside the nucleus we have got what? Protons and neutrons. And outside the nucleus we have got what? The electron. Okay, so let's go into more explanation. This model here illustrates nitrogen atoms, as there are what? 7 protons. So if you count, if we count the protons, we're gonna get what? 7. 1, 2, 3, 4, 5, 6, 7. Take note that they are all equal numbers of what? Protons and neutrons. So when in an atom we have the same number of nucleus, the same number of protons rather, and the same number of neutrons in the nucleus, then the atom will what? Be neutral. Okay, together they make up the nucleus of an atom. Protons have what? A positive charge. Electrons have a negative charge. and neutrons are neutral or no charge or zero. If the number of electrons equals the number of protons, then the atom is neutral and does not go off. Protons and neutrons are equal, then the atom is neutral. But take note, the atom can gain or lose electrons, resulting in a charge, and it is then called an ion. So an ion is a positively charged or a negatively charged particle. If an atom or an element loses an electron, it becomes a cation or cation, then it will carry a positive charge. If it gains an electron, it becomes an anion. Okay, so let's go on. So let's take note, subatomic particles. All right, now let's go on to look at what? Pure substances. What is a pure substance? A pure substance is a substance that cannot be separated into what? Simpler components by physical methods. For example, of a pure substance is copper. That is an element. Oxygen, of the oxygen gas, etc. Elements and compounds are what? Pure substances. So an example of a what? Of a pure substance are element and compounds. Okay. So what is an element? An element is a material that consists of atoms of only one kind. Okay. So I repeat again, an element is a material that consists of what? Atoms of only one kind. Or you can say an element is a substance that is made up of atoms of its own kind. So when we are talking of hydrogen, the hydrogen element is made up of atoms of hydrogen only. The same thing for oxygen, atoms of oxygen only. Carbon, sodium, and what? Chlorine. So take note. An element is a material that is made up of what? Atoms of only one kind or only one type. All right. So if you give an example of all the elements or of any element in the periodic table, then it's the same thing. All right. So let's go on. All elements are listed on the periodic table of elements. They are limited in number and are the building blocks of millions of compounds. So let's take note. Where can we find the elements? We can find them in the what? The periodic table. Now let's go on. Some elements on the periodic table of elements form diatomic molecules. Diatomic. Di means two. You remember mono, di, tri, tetra. So mono is one, but di is two. Okay. So how do we get a di? It means one atom from an reacts or is added to another atom to give you what? A molecule, which will give us a what? A diatomic. So an example is what? Hydrogen gas, H2. So remember the H2 is supposed to go down a bit. Nitrogen gas, oxygen gas, chlorine gas. So these are called what? Molecules of elements. So remember, if it is just Cl, that is chlorine atom, or the element of chlorine, which is made up of what? Atoms of only chlorine atom. So when you have got two atoms of chlorine coming together or reacting together to give you a chlorine molecule, that is Cl2, then they are what? They become molecules. All right. Sometimes atoms react together, to form what? Molecules of carbon, that is water, and CO2, carbon dioxide. All right. So let's go on. All right. All matter is made up of what? Particles with properties that help us to identify them. So let's take note. Okay. All right. So now we have just spoken about what? The element, the atom. Now I'm going to ask you some questions. All right, before we continue on. Okay. All right. So guys, I want you to do this. You just need to, sorry, answer the following questions. We will all start with number 1. Then after some few minutes or seconds, then we go to number 2. We go to number 3 in that order. So let's not just jump. Let's try to, all of us, to move on the same page. So guys, what we are doing now, you are supposed to answer these questions there so that we can finish up. Okay, guys, let's go to question 2. Give one example of a pure substance. Yes, I am giving you time to answer so that you can process everything. So it's bit by bit. I'm not pushing you people. Okay, so we said give one example of a pure substance. All right, so that's great. All right, now let's go to question 3. Most of you are given yeah, they are almost interrelated. Pure substance, yeah, and then okay, pure element. Okay, so let's give an example of an element. Yeah, I know, guys, you will get everything. Give one example of an element. All right, very good.